Hello students, welcome back to Quick Coaching. So in the previous lectures, all the topics that I had taken up were from class 11 physics. So now today I have decided to take up a very important topic in class 12 JEE physics. That is one of the first topics that is taught in class 12, which is electrostatics. So electrostatics is one of the vastest subjects that I've ever come across, but I will try to teach it topic by topic and by dividing it into a number of lectures. So today I am going to start electrostatics by a very basic law, which is known as the Coulomb's law. Okay, so we are going to start this chapter. Now we are going to start with Coulomb's law. Okay, now this is a very important topic and many students find it difficult to understand. And it is also very interesting because electrostatics has the widest variety of problems that come in JEE. So now I'll start with Coulomb's law. Now what is Coulomb's law? I am not going to go into the things that were taught in class 10 like charge conservation and those things, that total charge in the universe always remains constant. Okay, so those things are already known to you. So I am going to start with Coulomb's law. So what is Coulomb's law? So Coulomb's law states that the electrostatic force of attraction between two static point electric charges is directly proportional to the product of the charges and inversely proportional to the square of distance between them, and also acts along the straight line joining the two charges. Okay, so we will consider two charges, Q1 and Q2, okay, which are separated by a distance r. Okay, separated by a distance r. Let us consider they are separated by a distance small r. Okay, so Q1 and Q2 are two charged bodies which are point charges. Okay, these are 2 point charges which are separated by a distance r. So Coulomb's law gives us the force between, that is the electrostatic force of attraction between these 2 point charges. Okay, so I will draw these two charges. Okay, so suppose both charges are positive. This is Q1, okay, and here this is Q2. Okay, this is the line joining them. These are point charges. Okay, they don't have any dimension, so these will be the forces acting on them. Now we know this thing that like charges repel each other and unlike charges attract each other. So we have considered both the charges to be positive, hence they will be repelling each other by their electrostatic force of repulsion. Okay, so Q1 will repel Q2, so the force on Q2 due to Q1 will be along this direction, and the force on Q1 due to Q2 will be along the opposite direction. Okay, and if F is the electrostatic force between these two, Q1 will repel Q2 by F and Q2 will repel Q1 by F. Okay, so if F is the force between them, electrostatic force, so F is proportional to the product of charges. This is stated by Coulomb, and F is also proportional, that is inversely proportional to r square, that is the square of distance between them. The distance between them we have considered to be small r. Okay, so F is directly proportional to the product of charges and F is inversely proportional to the square of distance between them. This is also known as the inverse square law. So we can state Coulomb's law as, that is the force between these 2 point charges is given as K, Q1 Q2 by r square, where K is the constant of proportionality and K is equal to 1 by 4 pi epsilon naught in vacuum. Okay, now this is equal to, the value of this 1 by 4 pi epsilon naught is given as 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay, so this is the value of K, and K is known as the electrostatic force constant or the Coulomb's constant. Okay, because this is the constant of proportionality for finding out the force. Okay, and here epsilon naught, this quantity epsilon naught is known as the absolute permittivity of the medium. Okay, so the force is 1 by 4 pi epsilon naught q1 q2 by r square in vacuum, and if it is in any other medium, then we have by epsilon r square, where epsilon r is the relative permittivity of the medium. Okay, so this quantity, relative permittivity of the medium, this is also known as the dielectric constant of the medium. Okay, so the force between two point charges in vacuum is given as 1 by 4 pi epsilon naught, the product of 2 point charges, divided by r square, that is the square of distance between them. This is in vacuum, and F is given as 1 by 4 pi epsilon naught epsilon r q1 q2 by r square in any other medium. Okay, in any other medium. Okay, so this is Coulomb's law for 2 point charges. So students, we have learned Coulomb's law basics, and we have learned what Coulomb's law gives us. It gives us the force between 2 point charges in any medium or vacuum. Okay, so now we'll consider few examples to understand Coulomb law better. Okay, so the examples will be firstly on equilibrium of symmetric geometrical point charged system. Okay, point charged system. Okay, it will be on equilibrium of symmetric geometrical point charged systems. Okay, so first I will start with an example of an equilateral triangle. This is point charge capital Q. Okay, this is point charge small q, this is another point charge small q, and this is another point charge small q. Now it is stated that this charge capital Q is placed at the geometric center of the equilateral triangle, that is the centroid, and these point charges small q are placed at the three vertices of the equilateral triangle. So we have to find out the value of capital Q in terms of small q, so that the whole system is in equilibrium. Okay, so I am not writing down the question because I just now stated it to you, so I will just start with the solution. Okay, so here this is the line joining these two. So I am considering any one of the charges because this is a symmetric charged system. You can see all these point charges are at the vertices, and this is symmetric, whole system is symmetric. So any point charge must be in equilibrium for the whole system to be in equilibrium. Okay, so this charge small q must also be in equilibrium, this must also be in equilibrium, and this must also be in equilibrium for the whole system to remain in equilibrium. Okay, so I will consider any one of them. And what is equilibrium? Static equilibrium is a condition in which the net force on any charged particle is zero, or any particle is zero in a system. Okay, that is called equilibrium. So the net force on this charge due to all the other charges must be zero for equilibrium to be maintained. So I will write down all the forces first, and I will draw their vectors. Okay, now just now we learned that in Coulomb's law, the electrostatic force of attraction or repulsion between any two point charges acts along the line joining them. Okay, and we also know how to calculate the magnitude. So I will consider this length, that is the side length, as A. Now this will also be A. Okay, so both the forces, the force due to this Q and this Q will be along the line joining them. Okay, this line, and the force due to this Q and this Q will again be along this line joining them. Okay, and since this angle is 60 degree in an equilateral triangle, this angle between the vectors will also be 60 degree. Okay, this will also be 60 degree, and both the forces are equal since the distance between the charges are equal and the charges are also the same. So I will write them down as F. Okay, I will write them down as F. Okay, so what is F? Now F is equal to, the magnitude of F is given as 1 by 4 pi epsilon naught. I am considering vacuum, so 1 by 4 pi epsilon naught q square by a square. Okay, so this is the magnitude of F, or we can write this as kq square by a square, where k is 1 by 4 pi epsilon naught. okay, and the force due to capital Q on this charge, okay, will also be along this direction. I am drawing this here. The force due to capital Q on small q will also be along this direction, okay, this angle bisector, okay, it will also be along this direction. I am considering capital Q as a positive charge, so if the answer is negative, there will be a negative sign, okay. So what will be the magnitude of this force? So we have to find out the distance of this, okay, this distance from the centroid of this vertex, okay. So we know that in an equilateral triangle this angle is 60 degree, okay. So what is this altitude? What is this altitude? This altitude is a sine 60, and what is the value of a sine 60? It is a root 3 by 2, okay, root 3a by 2, okay. This is the magnitude of the altitude, and we know that centroid divides the altitude in 2:1 ratio from top to bottom, so this will be 2/3 of root 3 by 2a. So we have this distance as 2/3 of root 3 by 2a. So this distance I am writing it down as d. So d is equal to root 3a by 2 and 2/3 of it. So this becomes 2a by root 3. This is the distance, okay, that is d. So what will be the force? The force F1 due to q, capital Q on small q, the force will be F1 equal to, the force will be F1 equal to K, capital Q small q, divided by 2a by root 3 whole square, okay. So this comes out to be 3k QQ by 4a square, okay. So this is the value of the force that capital Q exerts on small q, and due to the other two charges, the resultant of these two forces will also be along the angle bisector, that is along the same line as the force acting on small q due to capital Q. So what will be that force? That is this force, the resultant. I am drawing it here, okay. So this is Fr, suppose, which is the F resultant. I am writing it down here. F resultant is equal to, the angle between the vectors is 60 degrees, so it will be f square plus 2f square cos 60. And what is cos 60? Half, okay. So half and 2 will cancel, so we have root 3 times f, and we also know the value of f in terms of q. So in order for this charge to remain in equilibrium, the small charge q to remain in equilibrium, the sum, vector sum of all these three forces must be 0, because I told you just now that equilibrium means net force on the charge is 0, okay. So here we have two forces acting along the same line. The resultant of these two forces, that is Fr, and the force F1 due to capital Q on small q, the sum of these two forces must be 0, that is Fr vector plus Fq vector. I am writing it down as Fq vector, that is the F1 vector, okay. I am writing it down as F1 only in order to avoid confusion. F1 vector is equal to 0, okay. Now they are acting along the same line, okay. So I can write down as the, I can write it down as the value of Fr as root 3f, okay. So root 3 k q square by a square plus the value of F1 vector, which is 3k qq divided by 4a square equal to 0. So now we are going to find the value of capital Q from here, okay. So what will be the value of capital Q? Capital Q will come out to be minus q by root 3. So we can see how we used Coulomb's law in order to calculate the forces between the point charges, and by using the condition of equilibrium, that is the net force on any charge is equal to 0, we found out the value of capital Q in terms of small q, and we can see that it came out to be a negative charge. So we had considered the force on small q due to capital Q in this direction, but as capital Q is negative, so the force will be in this direction. And we can also logically see that this is the correct explanation, because the resultant of this charge and this charge, the force due to these two charges on small q is along this direction. So in order to cancel the effect of this force, there must be a force in opposite direction along the angle bisector. So that is the force provided by capital Q, and that is why capital Q must be a negative charge. So our answer is exactly correct, and it is minus q by root 3, okay. So this negative sign implies that we had considered the force in the positive direction, but due to an opposite, there is a negative sign, the force will be just in the opposite direction along the angle bisector of these two forces, and that is why this force effect will be cancelled by the force due to capital Q on small q. So the net force on small q will be 0 and the system will be in equilibrium. So the value of capital Q must be minus q by root 3 for this equilateral triangle system of charges to be in equilibrium. So this is our first important problem for today. Now this is a very common kind of problem. This has also come in JEE mains many times. So this is very important in terms of competitive exams. So what is stated in the problem, we will first read it out. It is stated that two identically charged spheres are suspended by strings of equal length, and the strings make an angle of 30 degrees with each other. When suspended in a liquid of density 0.8 gram per cc, the angle remains same. So what we have to find out? We have to find out the dielectric constant of the liquid, and the density of the sphere is given as 1.6 gram per cc. So we'll first analyze the first case, which is two identically charged spheres are suspended by strings, okay, of equal length, and the strings make an angle of 30 degrees with each other, and the whole system is in equilibrium, okay. So we'll first draw it. This is a rigid support, okay. From here there will be two strings of equal length. This is one string, this is another string of equal length, okay. Both these strings are of equal length, and the strings make an angle of 30 degrees with each other, and here are the two charged spheres, okay, and the whole system is in equilibrium like this. Now how is the whole system in equilibrium? That means the force on the two charged spheres, net force on the two charged spheres is 0. So there will be the Coulombic force of electrostatic force, okay, which will be acting between these two spheres along the line joining them. So like this. We'll consider only one sphere. We are considering this because both are identical, okay. So we are considering this, and let us consider that the force initially is F, okay, that is in vacuum. When the system is placed, it is F, okay. So the force is F, and there will be a tension along the string acting on the sphere, okay, that is T. I am considering this sphere, okay. So, and this angle will be 15 because both these lengths are the same, okay, both these lengths are the same L, okay. So the central line will be the angle bisector, and these two angles will be 15 degrees each. So this angle will also be 15 from alternate angles. If that is 15, this is also 15 degrees, okay, because these two lines are parallel. So this is 15 degrees, and this is T. So we will resolve T into two components. This component of T acting along the vertical will be T cos 15 degrees, and this component of T acting along the horizontal will be T sin 15 degrees, and there will be another force, that is mg of the sphere acting downwards. So we can write down for equilibrium that T cos 15 must be equal to mg, because there is no net force in the y direction, and in the x direction also there will be no net force. So this will be T sin 15 equal to F. So if we divide this equation by this, we will find T will cancel, and tan 15 degree will be found out to be F by mg. Okay, tan 15 degree will be F by mg. Now this is the case when this whole system is in vacuum. Now if this system is only placed in the liquid of density 0.8 gram per cc, now the important concept comes into play, okay. So if this system, I am not drawing any separate diagram, I am just drawing the sphere, okay, because we are considering the equilibrium of this sphere. So if this system is placed in a liquid, okay, of density 0.8 gram per cc, then what will happen, okay. I'll write it down. Let us consider the string. Suppose the tension in that case is T1, okay. T1 is the tension in that case, and this is the electrostatic force acting between the two spheres F, okay. This is the force on this sphere F. This is mg acting downwards, okay. But since this whole system is immersed in a liquid, so there will be a bound force or upthrust, which you have come across in class 10, I hope. So what is upthrust? Upthrust is the force provided by the liquid on the object when the object displaces some volume of the liquid. So since the whole system is immersed into the liquid, there will be an upthrust on this sphere, okay. So what is the value of that upthrust? Upthrust is given as V rho g, that is V is volume of the object immersed in the liquid, rho is the density of the liquid, into g, that is acceleration due to gravity. So I am writing the density of the liquid as rho L, okay. So that upthrust will be acting upwards, and that will be V rho L G. That will be the upthrust acting upwards. V is the volume of this sphere, okay, that is acting upwards, okay. And this force, this will not be F, this will be F by the dielectric constant of the liquid. And what is the reason? I told you in the previous topic when I was teaching you Coulomb's law, that the force in vacuum, if it is F, then in order to find out the force in any other medium, it becomes F by epsilon R, which is the absolute permittivity of the medium or the dielectric constant of the medium, okay. So we also denote dielectric constant by K. This is the dielectric constant of the liquid, okay, dielectric constant of the liquid. So the force on the sphere will be F by K when immersed in the liquid, and we have to find out the value of K. And it is also told in the problem that the angle remains the same, that is the angle between the strings remain 30 degree when they are in equilibrium. So again this angle will be 15 degree, this angle will again be 15 degree. Okay, now we will resolve T1 into two components, that is T1 sine 15 degree and T1 cos 15 degree. Here T1 cos 15 degree, which is again upward, okay. So we'll write down the equilibrium equations for the second case. In the y direction we have two forces, T1 cos 15 degree and V rho L G, which is the upthrust, and downward mg, okay. So we have found out one equation in the second case. I am writing it down as the second case, okay, that is T1 cos 15 degree is equal to mg minus V rho L G, okay. This is T1 cos 15 degree, and by considering the forces in the horizontal direction, we found out that T1 sine 15 degree is equal to F by K, where K is the dielectric constant of the liquid, which we have to find out. So we divide these two equations in order to eliminate T1, because we do not know the value of T1, we have to find K. So if we divide these two, we find that tan 15 degree is equal to, tan 15 degree becomes F by K times mg minus V rho L G, okay. So these are the two equations which we have found out, okay. So we are given the densities of the two objects, that is the density of the sphere, density of the liquid, okay, and we are given the angle. So we have to eliminate this mass m, okay. So we'll first equate these two equations, okay. So we have found this is equation 1 and this is equation 2. So if we equate 1 and 2, what we find out, because it is given tan 15, we can equate these two, that equals, so F by mg is equal to F by K times mg minus V rho L G, okay. This is the equation. So now we can replace m by V into rho, because mass we know is the product of volume into density. So we can write down F by, I am writing the volume of the sphere as V, which I had used previously, and I am writing the density of the sphere as rho s, okay, rho s, because rho solid, rho s g is equal to F by K times V rho s g minus V rho L G. So you can take V common, G common from here, which will cancel from both sides, and F will also cancel from both sides. So what we are left out with, this is 1 by rho s, okay, is equal to 1 by K times rho s minus rho L. So we get the value of K as 1 by 1 minus rho L by rho s, okay. So we can easily find out the value of K from here, because we are given the values of density of sphere and density of the liquid. So we'll put it here. The density of the liquid is given as 0.8 and the sphere is 1.6. So 0.8 by 1.6, okay, this is half, so 1 minus half is again half, so K becomes 2. So we have found the value of K equal to 2 and solved the problem very easily by just using the concept of Coulomb's law and the concept of static equilibrium, that is the net force on any object is 0 in equilibrium. So this is how we can solve any problem regarding Coulomb's law and equilibrium very easily. So friends, in today's lecture we learned a very important topic in electrostatics and one of the very basic topics in JEE physics, that is Coulomb's law, and we also solved a few problems on Coulomb's law and saw how to do them in competitive exams. So in the next lecture I will come back to you with some more topics on JEE physics, and we can learn more amazing tricks, problem solving tricks for competitive exams. So guys, please let me know in the comment section how you feel about my videos and whether you like them or not, and please like, subscribe and share the channel with your friends if you find the videos helpful, and enjoy learning physics and do the more problems so that you become confident on each topic. So goodbye guys, I'll come back to you with more lectures and more amazing tricks. Bye bye.